Hello, you're welcome. This time around, we want to look at finding the GCD or the HCF of any two given numbers. GCD, I mean greatest common divisor, whereas HCF refers to highest common factor. The approach, however, is going to be that of the Euclidean algorithm. The Euclidean algorithm is in the form A equal to B multiplying X plus R. These are symbolic representations, so they are variables which can change. In this case, A represents the greatest or the biggest number out of the two numbers given for us to find their HCF or GCD. The X represents number which B will have to multiply to get as close to A as possible. R represents a certain number which is the remainder of how far B times the X went close to the A. Let's take an example to make it more appealing. You may be asked to find the GCD of these numbers 20 and 6. What we do is to bring the 20 outside, equate that to 6. We ask ourselves what number or how many times 6 perfectly enters 20, which is 3. The product of 6 and 3 will give us 18, so we have a remainder of 2. We continue by bringing the 6 here down to this side. We therefore bring the remainder down here to occupy the former position of the 6. We then ask how many times 2 will perfectly enter 6, and that will be 3. We ask whether or not there will be a remainder, and there wouldn't be any remainder, therefore 0. Next, we bring the 2 which was already or which is now in the position of the 6 to where the 6 is currently occupying. We then try to bring this 0 down here and ask ourselves whether we will get any number to multiply 0 to give us 2. As far as I know, there wouldn't be any. This indicates that the GCD or the HCF of 20 and 6 will be 2. In another example, the HCF of 50 and 15 can be obtained as follows. 50 is equated to 15, and we ask ourselves how many times 15 will enter 50 perfectly. That should be 3. The product of 15 and 3 is 45. and the remainder to get to 50 is 5. Next, we bring this 15 down here. Next, we bring this 5 to replace the former position of 15. We ask ourselves how many times 5 will equally go into 15, and that is 3. The product of 5 and 3 is 15. That means there is no remainder. The next thing is we bring this 5 down here to the former place of 15. We then try to bring 0 down here. We ask ourselves whether or not 0 can multiply any number to give us 5, and there wouldn't be any. At this point, we can conclude that the HCF or the GCD of 50 and 15 is 5. Let's look at the last example. We are attempting to find the GCD of 120 and 50. Like we have already established, we start with the biggest number, which is 120, equate it to 50 times a certain number. The number is asking how many times equally can 50 enter 120, and it is 2. The product of 50 and 2 is 100. So it means there is a remainder of 20 to make up the 120. Next, we bring 50 down here, equate it to the former remainder, which is 20. Then we ask ourselves how many times 20 will enter 50 perfectly. That is 2. Plus the remainder. 20 times 2 is 40. The remainder of 10 to make up the answer. Now bringing 20 down here, equating it to 10 times a certain number. How many times will 10 enter 20 perfectly? It's 2. The product of 10 and 2 is 20, which means there is no remainder. We come down and we realize that bringing down the 10 to this side, equating it, then bringing 0 to this place, then asking ourselves whether or not we get a certain number, there is absolutely no number. That implies that the GCD for 120 and 50 is 10. Before we go, let's try to establish some generalizations. You realize that anytime you get a remainder of 0, it implies that you are near your GCD or HCF. So, at any point in time where you have 0, the number 0 as a remainder, the number which was the previous remainder is the GCD. As observed here in the first case, when we had 0 as a remainder, the previous number which was a remainder was 2, and it ended up being the GCD. Equally, the second example establishes a similar fact. When we had 0 as a remainder, the previous remainder was 5, and it ended up being the GCD. The last example we looked at also brings out the similar observation. That is, after having 0 as the remainder, the previous remainder, which was 10, ended up being the GCD. Thank you for watching, and see you next time. Bye.